Next one is partition by load balance. So as I the first session I would have said that why we need partition data means like if we want to execute the data parallelly. If we can process the data parallelly, then we'll go with that is data parallelism. To achieve the data parallelism, we need to partition the data. Like that means we need to convert a single serial file into multiple files, different partition files, which is having data. So if we like here, we are running data from different partition, all the three partition we can execute parallelly. So that means how much how in the real time how we can design how many partitions should have that it should have how many partition means like in the Unix or Linux system it depends on the number of CPUs. So mostly the data will get segregated. The number of partitions will be decided based on the number of CPUs that particular processing server, particular processing server, yeah, Linux or Unix, it has. Like let's say mostly they will have two CPUs, 2, 4, 8, 16, 32, and 64 bit, right? So mostly these are the number of partitions will be there in real time. So mostly in the development environment, they will have two-way system, like two partitions will be there. And in the test environment, mostly 4 and 8, and real time in production, they will have 8, 16, 32. At the maximum, they can go for 64 partitions. So that's how the partitions will be, the number of partitions will be decided by the ABInitio activity. So number of partitions will be decided based on the maximum number of CPUs that particular server has. So this particular partition component, like partition by load balance. So what it will do, it will check. Let's say we have 4 partition output file, and that means 4 CPUs will be there. This particular partition by load balance, what it will do, it will check the load on all the 4 CPUs. Let's say one CPU is having heavy load, some other process, that particular Unix server is not only for this particular ABInitio graphs, right? So some other application, some other Java code, some other Python code, or some other application might be running on that Unix server. So let's say one of that application is consuming more CPUs, more cycles, CPU cycles in one, only one CPU. So the remaining 3 CPUs are having, it is having more space. Only one CPU is having heavy load. So what this particular component will do, it will send only few records to that particular partition. So whichever partition, whichever partitions CPU is having heavy load, was that for that particular partition, lesser number of records will be sent, and the remaining partitions, which for their CPUs having more CPU cycles, right? So whichever CPUs are free, so that particular partition will get more records. So that the data will be equally distributed based on the load, so that it will get optimum value, optimum time to complete the particular process. Let's say in this scenario, if you use partition by round robin, so what will happen if you have 100 records? All 25, all 4 partition will equally get 25, 25, 25 records. So now the remaining 3 partition, 2, 3, and 4, which CPU is having lesser load, right? So it will complete faster. But the one partition which is having heavy load due to some other process, some other non-ABInitio thing is running, so it is taking it went to a hung state or something, it is taking more time. So what will happen? That particular component will keep on waiting for that particular partition to execute. So it will take some more time, right? So to avoid that situation, we can go with partition by load balance component. So based on that, at that particular time of execution, it will see, this particular component will see what is the load on all the CPUs. So based on that load, it will distribute the data accordingly. You got the difference. You got it, right? Right?
Yes.
Okay. Let's see how to disable this. What is it? Balance. So here it's running on Windows, right? So it will have only one CPU here. So it will send all the records to only one partition. So it will not send the data to many partitions. But in the real time, it will calculate the load on all the partitions. Let's see.
How?
Like how in the sense, I didn't get your question.
You said only one partition because of one CPU we are running in Windows actually.
So
Where
here
can like
in
what?
this, okay. So
Yeah,
here we have installed this GDE like ABInitio on Windows, right? Not on Unix system, right?
understood. Yeah, correct.
Yeah. So that's why like it will send only one party. Like it is having only one CPU, so it will not able to partition. It will not able to check
The
the load on other CPU. So it's got
okay,
it
okay.
right. That's why
Like
like it sends like yeah.
so the output file will be only two or what?
Like even if you have multiple output file, it will send the data to only one partition. So we have only
Okay.
one CPU here, so it is not able to check the load on the other CPUs. Like if we give n number of outputs, it will not be able to check. And we have only one CPU, and it is free, so it sends all the records to this particular partition.
Okay.
So AbInitio thought that these CPUs are loaded, like these CPUs might be loaded, and it doesn't have any space to execute it. So it sent like it is able to check the load on this particular only one CPU, that one existing CPU. So that's why it sent all the records to that particular partition.
Okay.
But in the real time, like if you have multiple CPUs, this particular partition will be working. So here, like this is not like I never use this partition command, but this is the scenario. Like if you got any, like say for example, you gonna schedule this job on particular. Let's say daily 3 p.m. this particular job is gonna schedule, and daily at the same time some other application, some other job is gonna execute at the same time. Like some other team they have also scheduled that particular Python code or Java code which will execute at the same 3 o'clock. So both will came to a clash, right? So at that time like if you have a scenario like that, then you can go with partition by load balance. Either you can instead of scheduling at 3 o'clock, you can schedule it some other time. Once that particular other code got complete, once after the completion of that code, then you can schedule it. Or if you have a strict time, like if you have to schedule it at 3 o'clock, then you can go with this partition by load balance component. But you got it right.
Yes, understood.
Yeah, so you could see like version it will be distribute the records based on the it will be here. Like if you see it will show like how this a load level based on the load level it will identify the number of records like how many records should we like it should allocate to each and every partition. So these are the different partition components we have, and in the latest version we have along with this